This is where we ended. So let me just check if it's recording. All right, it is. So this is where we ended yesterday. And remember what we said. Okay, the question was saying the first three terms in the expansion of this. The first three terms in the expansion of this are these here. So this simply means that, and then they're asking us first to find the values of A and B. So this first statement here simply means that when you expand this, you expect your first three terms to be these. So in short, what they're asking me to do is to expand this up to the third term. I'll just get the first three terms in the expansion of this. I'll just get the first three terms in the expansion of this and then equate them to that. Okay. So before expanding this, we just do a quick recap on what we did yesterday. You first have to equate this part. You first have to equate this part to A, or to any letter of your choice. So I'll say let A be equal to this part here. This is x plus, then B x squared. And then after that, after doing this, after letting this to be equal to that, meaning I'm going to put A on this part here. So I'm going to have something like this, 1 plus, while there is x plus bx, I'm going to replace with A, and then close brackets like that, and then to the power n. Then this is equal to, so the question is saying that when I expand this, I'm supposed to get 1 plus 7x plus 14x squared. So this is equal to 1 plus 7x plus 14x squared. So this is what I'm supposed to get after expanding that. And then the question is asking me to find the values of A and the values of B, and the value of A and the value of B. So now we can expand this part. So how do I expand this part? Remember yesterday we looked at the extension of the binomial theorem. Okay, let me just do this. Okay, so we looked at the extension of the binomial theorem, which is this one here. I wanted us just to take a look at it. This part here, this is the extension of the binomial theorem. And we said it only works when the value of A here is equal to 1. That's the only time you can use it. And then on the application of this formula, we said it can also help you to expand the given expression when the power here is a negative integer or a fraction. So when you see a power here is a fraction or a negative integer, just know that you only have one option to expand that expression, which is by using this same extension here. So now let's move on to how it ended. So we proceed. So let us try to expand this using the extension. So by using the extension, our first term is always 1, and then plus nx. So n, my x in this form is a. So I'm going to say n a, and then plus, I'll write my n there, then open brackets, n minus 1, and then close brackets like that. My x there is a, and the power keeps on increasing, the power of a, then over everything over 2 factorial. Then we said 2 factorial is just the same as, so 2 factorial is just the same as 2 times 1. So 2 factorial is just the same as 2 times 1. Then the expansion keeps on going like that. The reason why I've ended on the third term here, because I've only been given 3 terms this side. Then I'll equate everything to the right hand side, which is 7x, sorry, which is 7x. Okay. So equate everything to the right hand side, which is 1 plus 7x, and then plus 14x squared. So now what I'm remaining with is just to simplify this part this side. So I know to say my a, this a here is just equal to this. So meaning at every point where there's a in this expansion, I'm going to replace with x plus bx squared. So I'll write it there. N, and then where there's a, I'm replacing with x plus b x squared, and then plus. Please, if you have any questions or any concerns about what you are learning right now, you can raise your hand. There's an option there for raising your hand. So n plus, so nx plus bx squared, and then plus, you write that n minus 1, then everything over 2. Then this a is raised to power 2. So meaning, and then I know to say my a is nothing but x plus bx squared. So while this a, I'm putting x plus bx squared. X plus bx squared. Then I'm equating everything this side to 1 plus 7x plus 14x squared. So here now we can collect the terms this side which are having the same degree. And then what do I mean by that? Oh, here there's also a squared here. There's supposed to be a squared since this a is squared here. So I'm going to collect the term with the same degree this side. But remember, this part is squared. This part here is squared, meaning I also need to simplify this part before anything. So how do I do that? So how do I do that? I'm going to, let me do this. So I'm going to expand this part here. Let me just expand it from here. Okay. And then, so I'm having x plus b x squared. So expanding this is just the same as open brackets x plus b x squared. This same function is multiplying itself 2 times plus b x and then squared. Sorry, it's supposed to be squared, not cubed. So squared and then in brackets like that. And then, so now we start multiplying these. And then remember, in this expression that have been given as the solution of this expansion, I only have x and x to the power 2. So even when multiplying this, I shouldn't get all the terms. I'm only supposed to get the terms that are having x, and the terms that are having x and x squared. Those are the only terms that I think would be best for me to get. So I'll get, when I multiply x times x, I'm going to get x squared. But when I multiply x times bx squared, I'm going to get plus bx to the power 3. When I multiply these two, I'll get another bx to the power 3. I'll get another bx to the power 3. Then when I multiply bx squared times bx squared, I'm going to get b squared, and then x to the power 4. But the terms here that have been given are only going up to the degree that is 2, which is, they are only going up to x squared. So meaning all this is irrelevant. I'm only supposed to get x squared then. So I'll rewrite this. It's going to be 1 plus. So n times x there, I'm getting n x. N times bx squared, I'm getting plus n b x squared, and then plus, then this I will not expand it, but if you want, you can expand it, there's no problem. You can open the brackets, but for me, I like leaving it like this because it's easier to simplify when it's like this. It's already simplified. Then over 2, and then here, instead of writing everything this side, I'm just going to get x squared. That's all. I'm just going to get x squared, and then is equal to, this is 1 plus 7x, and then plus 14x squared, plus 14x squared. So I'll start now equating the terms from the left-hand side to the right-hand side, which are having the same degree. So I'm going to get first this. So this one, as you can see here, this one is equal to that one. So there's no problem with that. If you want, you can write it, but there is no point of us writing that. We need to find the n. So meaning I'm getting the second term here. I'll equate it here to the second term. So my nx is equal to this 7x alone. Why have I equated it to 7x? Because I've seen that these terms are having the same degrees, meaning the degree here is 1, even this side, the degree there is 1. So I'll divide both sides by x, divide by x, then my n would just be nothing but 7. Actually, the question here, they made a mistake, I think, when making the question. They were supposed to say, find the values of n and b. This is supposed to be n and not a. This is supposed to be n. So we found our n here. Now we're just remaining with finding b. So I'm also going to get the terms here with a degree 2, meaning they are squared. Even this side, I'll equate them. So I'm going to have n b x squared is equal to, sorry, not equal to, and then plus, then plus we're going to have plus here, and then n minus 1 like that, n minus 1, and then I'm going to have n minus 1, and then x squared as well, and then over 2, and then I'll equate these to 14x squared. So here when you divide by x squared, x squared, x squared, these will cancel. So what I'm going to remain with is this nb this side, and then this side we're going to remain with n minus 1 over 2. Then this side we're going to remain with, on this part we're going to remain with 14. So where there is n, we've already found that n is equal to 7. So where there is n, I'm going to be putting 7. So 7b is equal to, so I'll put 7 there, and then open brackets, 7 minus 1, I'm going to get, so 7 minus 1 will give me, is it 7 minus 1, which is 6, and then everything divided by 2 equals to 14. So now after that, you can now simplify this by finding the value of, oh, sorry, this is not supposed to be equals, supposed to be a plus. Okay, so we're now going to find the value of b here. So when you divide these two there, you have 1, then these two there, you have 3. So you're going to have 3 times 2, that is 20. Oh, sorry, 3 times 7, you get 21. So this is 7b plus 21 is equal to 14 like that. So you take this 21 that side, you are going to have, you take this 21 on the other side, you're going to have something like this. 7b is equal to, when you take this 21 this side, you're going to have 14 minus 21. So 14 minus 21 will give you negative 7. Negative 7. Then when you divide both sides by 7, you find your b to be a negative 1. So you found your n and your b. This is how you go about with this question. All right, I hope we all have no questions here. We all have no questions here, I hope so. So now, we can proceed. So this is the solution here. I just solved it on a piece of paper and decided to put it there. So this is the solution for this question. Actually, this is a question from your tutorial sheet. It's question 8, by the way. Okay, we proceed. So you can use the same extension to solve such questions as these here. You can use the same extension to solve these questions here. Now, how is that possible? How is that possible? Let's take, for instance, the first part here. Well, the question is saying, expand in ascending powers of x as far as the term in x to the power 3, using the binomial theorem. State in each case the limits of x for which the expansion is valid. So here what you do is simple. You get this question, for instance. This is question I. So I'm going to get this question like that. Then it's going to be 1 plus x, 1 plus x, then everything squared. 1 plus x and then everything squared is equal to, so this one in other ways we can write it as, 1 plus, sorry, 1 plus, this can also be written as 1 plus x, and then everything in brackets, then to the power negative 2. And remember what we said. We said the extension can also be used to, the extension can only be used when this value of a here, the first part of the expansion, is 1. So this here, a is supposed to be 1 always for you to use the extension. And then the power here can be any number, either a negative number, a fraction. Yeah, the extension can be used. But the binomial, the main binomial theorem is restricted in some way, because when you have the power, to be negative, it doesn't work. But this extension does work. It does work when you have a negative power or a fraction there as your power. So now, since we have this expression, and it's in the form which is valid for the extension to work. Yeah. So we can start expanding this. So our n, first let us identify our n. Our n in this expansion, our n is equal to negative 2. Then we can use the extension now to expand this. So the extension to expand this binomial expression. So in this extension, always the first number is 1. This is the first term. And then the second term is always nx. Let me just write it here for the sake of revision. So the first term here, when you have 1 plus, so when you have 1 plus, a, like that, when you have 1 plus a, and then to the power n. So the way you deal with such questions, the extension formula is in such a way that the first term is 1 here, and then the second term here is nx, and then the third term there is n minus 1 in brackets, and then there's n outside this side, and then everything over 2 factorial. And then there is our a here, which is this is supposed to be a. We're not using x. This is a, and then our a here squared, and then it goes on like that. So here they are asking us to reach. So they are asking us to reach up to the term in x power 3. So we can start now expanding our function here. So the first term is always 1, as we have seen. Then the second term is NA, meaning our n, we identified our n to be negative 2. And in this case, according to this, equated to that, our a is equal to x. So while there's a in this expression, I'm going to be putting x, and then while there's n, I'm going to be putting negative 2. So our n is negative 2, like that, and then open brackets. My x is just x, like that. And then I'll say plus, my n is negative 2, and then n minus 1. So n minus 1 is just the same as negative 2 minus 1, which will give me negative 3. In the expression here, there is n minus 1. So n minus 1 is just the same as negative 2 minus 1, which is negative 3. And then I'll put my x there. And then my x is what? Is squared. Then everything divided by 2 factorial. And then plus, I've been asked to reach as far as the term x to the power 3, so I can't end here. So my n again is negative 2, and then I'm going to have n minus 1 is negative 3, and then n minus 2 is the same as negative 2 minus 2, which is negative 4. And then I'll divide everything here by 3 factorial. And then my x this side will be raised to the power 3. So I've reached the term they wanted me to reach. I'm just remaining with simplifying the expression. So this is 1. So 1, when you multiply negative 2 times x, you get negative 2x as your answer. Then when you multiply negative 2 times negative 3, you get negative 6. And then 2 factorial is just 2 times 1. 2 times 1 is 2 factorial. And then x squared there. We proceed. So negative 2 times negative 3, you get your negative 6. Your negative 6 times negative 4, you get, negative 2 times negative 3, you get positive 6. And then positive 6 times negative 4, so here there's a mistake, negative 2 times negative 3, we have to get a positive number here. Sorry for that mistake. And then here, negative 3 times negative 2, you get a positive 6. And then positive 6 times negative 4, you get your negative 24. Negative 24, and then everything over 3 factorial is just the same as 3 times 2 times 1. But again, if you don't want to start dividing numbers again, like what? If you don't want to waste time dividing numbers, you don't want to be making mistakes, especially, I think the best advice I can give you before you even do this is you first divide this. So this 2 factorial is just the same as 2. You know that 2 factorial is just the same as 2 times 1. So this 2 can cancel with that 2. You remain with negative 1 there. Negative 1 times negative 3, you get your positive 3 there. So it will be positive 3x squared. And then you come here, you know that 3 factorial is the same as 3 times 2, and then times 1. So meaning these 2 can go into the, no, before you divide that, I think these 2 can cancel with that 2. You remain with negative 1 there. And then these 3 can cancel with that 3. You remain with negative 1 there again. So when you multiply everything there, you discover that your answer will be a negative 4. You just remain with negative 4x to the power 3. It goes on like that. So this is how you solve such questions. And then they would ask you, for instance, here, the last part is saying, state in each case the limits of x for which the expansion is valid. So the limit of x for which the expansion is valid, you just get this part here. So you just get this part and put it in the absolute value symbols and say this is less than 1. So this So this expression here is only valid when x is less, when the absolute value of x is less than 1. All right. So this can also be written as, when you remember in the functions, last semester you did functions, you can write this as that. You can write it in this form. And then you have something like this. That is your final answer. So if you want, you can end here, there's no problem. This can also be written in set notation as that. So you can say x is such that, or x is equal to that. So this is your solution. All right, let's proceed. So that is what I'm just from explaining. You write it in that form, and then this is going to be the formula that you're going to be using. Then you put in your values like that. You simplify it. Then that's going to be your answer. This is what we found. And then it's only valid when the absolute value of x is less than 1. Then you write it in that form. So this is what it means. So we move on to the second question. So on this question, again, you need to pay particular attention. So this question is a little bit different from the one that we are just from solving. This one which are from solving, there's a 1 on top here. But in this case, we have a 5 there. And then apart from having a 5, there's also a 2 there instead of a 1. So remember what I said yesterday. I said if you want to, I said this extension of binomial can be used to solve most of the questions in binomial. Can be used to solve most of them. So here the time is showing me that I'm remaining with about 1 minute, but no problem. I already have another link. I'm going to share it as soon as this meeting ends. So I'm going to share the link again. So this is 5 over 2 plus x and then raised to power 3. The extension of the binomial formula, we know that it is 1 plus a, then everything raised to the power n. So this is how it looks. Then you expand it in that way. You expand it like this. So this is how the extension of the binomial theorem, this is supposed to be a. This is how the extension of the binomial theorem looks. Then over 2 factorial. Then you go on like that. So now we have to express this part here, this question in this form here. It has to look like this for us to use this this formula. For this formula to be valid, we have to express this question in this form. And how do you go about with such questions? This is how first you write your 5 there, and then you make sure that this is in this alignment, and it simply means that when this goes up there, the power will be negative. So we're going to have something like this: 2 plus x, and then to the power negative 3. Like guess for those guys who are online on Zoom yesterday, we learned on how you can change this 2 to become a 1 here. But I will also go through today for the sake of those that missed yesterday's lesson. So I'll write my 5 there, then I'll open these big brackets. Then I'll factorize these 2 there. I want to remain with 1 there, meaning I'm going to divide these 2 by 2 and then even this x by x. So I'm going to write these 2 there. Then when I divide this 2 by 2, I'm going to get a 1. When I divide this x by 2, I'm going to get a x over 2 as my answer. So this is such that when I multiply 2 times 1, I'm going to go back to 2, and then when I multiply 2 times x over 2, this 2 will cancel with that 2, and I'm just going to remain with x there. So this is how it is. So now all this is raised to power -3. And then apart from that, you write this 5, and then these 2 will be raised to power -3. We know the rules of indices to say that when there's multiplication inside the brackets and then there are always, let me just write it here. When you have maybe x times y, then raised to power n, this can also be written as x, you raise it to the same power n, and then the y is also raised to the same power n. So this is what is going to happen here. These 2 will be raised to power 3, and everything in the brackets will also be raised to power 3. So this is going to be in brackets like that, and then we're going to have 2 to the power -3, and then we're going to have open brackets there, and then 1 plus x over 2 to the power -3, like that. Then we know that 2 to the power 3 is equal to 8. So we're going, in other ways, this can be written as this. So this is just going to be 8 to the power -1. 8 to the power -1 can also be written as 1 over 8. So 8 to the power -1 can also be written as 1 over 8, like that. Then you open bracket, then you have 1 plus x over 2, then everything raised to power -3. Now here we're just remaining with opening the brackets. So when you open the brackets here, you are going to have, when you open the brackets, you are going to have 5. We're going to have 5 over 8. When you multiply 5 times 1 over 8, you are going to have 5 over 8. And then you open the brackets there, you have 1 plus x over 2, and then everything raised to the power -3. And then at this point now, we've seen to say this part has been expressed in this form. So meaning it is easier for us now to use this expansion to expand this expression here. So what you do here is you just expand this part, and then after expanding this part, you come and multiply everything by 5 over 8. What do I mean? Let me just do it quickly here. So I'll write 5 over 8 there, like that. And then I'll open these types of brackets. And then I'll begin expanding this. So my A there, my A, let me just do this. So my A, okay. So my A is equal to x over 2. And then my n is going to be -3. So meaning in this expansion, where there's a, I'm going to be putting x over 2, and then where there's n, I'm going to be putting -3. So I'll begin expanding this now. So the first term is always 1. And then the second term, it is n times a. So n times a is just the same as -3 times x over 2. negative 3 times x over 2. And then I'll put this negative 3 in brackets as well. And then apart from that, we're going to have a plus here. And then we move on to the third term. The third term is saying you write your n, negative 3. And then n minus 1 is the same as negative 3 minus 1, which is negative 4. And then your a there is x over 2, and then everything raised to power 2. And then divide everything by 2 factorial. Then you add it in that way. So the third term, since the question was telling us to end up to x to the power 3, so meaning we're moving on to the last term according to the question. So the first one here should be negative 3, and then followed by, let me put this in brackets, negative 4, and then negative 3 minus 2, we are going to have negative 5, like that. Then your x here is, your a here is x over 2, and then everything raised to power 3, like that. So this is our last term according to the question. And then we write 3 factorial there. So 3 factorial is just the same as 3 times 2 times 1. So 3 factorial, and then this 2 factorial is just the same as 2 times 1. Then it goes on like that. Then you close the brackets like that. Then this is equal to, you can simplify this. Then when you simplify that, you get something like, you can simplify that. Then you get something like this. So this is going to be 5 over 8 outside. And then you open the same brackets. So negative 3 times x over 2, you get your negative 3x over 2. Then when you multiply this, you're going to get a positive. These 2 into 2, you get 2 as your answer, the negative 2 there. And then you have, when you square this x over 2, you're going to have something like x over, you're going to have x squared over 4. When you open the brackets of this, so we know that these 2 will come and cancel with 1, 2 there, and then you remain with a 2. Then here you remain with a negative 1. So you multiply negative 3 times negative 2, the negative 3 times negative 1, you get your positive 3, and then x squared, then over 2. This looks to be interesting. And then we move on here. This 3 cancels with that 3. You get your negative 1 there. This 2 cancels with 1, 2 there. You get your negative 2 there. And then we have 8 here. 2 raised to power 3, or this thing raised to power 3, you're going to get something like x to the power 3, and then everything over 8. So now, this negative 2 can also cancel with 2 into 8, you get your answer to be 4. So we're going to have negative, so this is 5 times x to the power 3, you're going to have negative 5 x to the power 3, then everything over 4, like that. So this is what you're going to have. And then you just, here it's just a matter of multiplying throughout. When you multiply, you have 5 times 1, 5 over 8 times 1, you get your 5 over 8, like that. And then 5 over 8 times this, you get your 15 over 16, Yeah, 15 over 16. So this will be minus 15 over 16, and then x. So this is how you do it. You keep on multiplying. Then after multiplying, you're going to have your answer. After multiplying everything, you're going to have your answer as this. So this is going to be your answer. 5 over 8 minus 15 over 16 plus 15 over 16x squared, and then minus 25 over 32 x to the power 3. So this is going to be your answer. And then this expression is valid when this part here, this part here is, let me write here. So this expression is only valid when x over 2, when the absolute of x over 2 is less than 1. So when you cross multiply here, you find that the absolute of x is less than 2. So when you have something like this, it simply means that your answer is going to be -2. The range of this is going to be -2 less than x, and then less than +2. This is going to be your range. This is going to be your range. So if you want, you can put it in set notation, which is just the same as -2, -2, that is in set notation. Then you put these kinds of brackets, don't put the square brackets. So this is how you go about with these questions. This is how you solve these questions. Okay? So now, we move on to this question. So this question, I'll show you how to solve it up to a certain point, because I don't want to waste much of your time today. Actually, we're not supposed to meet today. We were supposed to finish this yesterday. Now, due to the power cut which happened, we failed to finish it up. Anyway, so I'll just show you how to do this quickly. So this is the fourth question on that question. And actually, what I'm doing is that I'm using the questions from your tutorial sheets as examples. So this is also a question in your tutorial sheet. So the way you go about with this question, first you express it in the form. So this is 3 plus 2x. So you express this in the form that is that is going to be valid for the extension which is in this form to work. So you should express that in this. This value of n here can be a fraction, it can be a negative integer. So this, you express it in the form of this. So this is going to be 3 plus 2x. Remember, this square root here is just the same as half. It's just the same as raising all this to the power half. Okay, so let us proceed. So what you do here, again, we need to get rid of these 3. But how do you do that? You open the square brackets, you write your 3, then you factorize the 3. Now, how do you factorize it? It's just the same as dividing everything here in the brackets by 3. You divide 3 by 3, you get your 1 there. 2 divided by 3, you get your 2 over 3. 2 over 3, and then x there. Then in brackets like that. And then you do that. Then 1 over 2, like that. So you distribute this power into the brackets there. You're going to have something like this. So this is going to be 3 raised to power half, and then open brackets, 1 plus 2 over 3x, and then everything raised to power half. So that's it. Then you keep on simplifying this. So this can also be written as this 3 to the power half is just the same as the root of 3, and then open brackets 1 plus 2 over 3 x, and everything to the power half. So now we can see that our question now here is in the form 1 plus a to the power n. So now it's easier for you to use the extension. So you do it the same way I did the previous question. You write your root of 3 there, then open these brackets. Your first term there is 1. Your second term is nx. So nx is just the same as half times my x there is 2 over 3 x. That is my a there is 2 over 3x. And then plus your n. So your n is half. And then your n minus 1, which is a half minus 1. I think you get something like, so half minus 1, you get something like negative half. So you're going to get negative half there. And then you write your x there. Your x is 2 over 3, and then x to the power, and then everything x to the power 2. Then you write over 2 factorial. Since they are telling us to end on x to the power 3, you keep on writing like that. So your n is half, then negative half there, and then this is going to be 2 over 3. Oh, sorry, before I write that, again, you subtract this half minus 2. So you have half minus 2. Your answer is going to be negative 3 over 2. You're going to have negative 3 over 2 there. And then your x, sorry, your a is going to be 2 over 3 x to the power 3. Then everything divided by 3 factorial. So this is negative 3 over 2. Okay. So you keep on going like that. But since the question is saying we end on x to the power 3, so you can end here, and we're just remaining with simplifying the expression. So you multiply everything, you simplify them like that. Yeah. So this expression is only valid when this part here, so it's only valid when this part here is, the absolute value of this part there is less than 1. So the absolute value of 2 over 3, so the absolute value of 2 over 3x is less than 1. This is the only time when the expression or when the expansion is valid. So this, when you cross multiply, you're going to have x, you're going to have the absolute value of x, you're going to have the absolute value of x being less than 3 over 2. So this can also be written now in this form. Over 2 less x, then less 3 over 2. So if you want, you can write it in set notation where you say x is nothing but equal to a set of numbers between negative 3 over 2 up to positive 3 over 2. So this is the other way in which you can write the answer. So we proceed. So this is what I'm just from showing you. You write it in that way. You find your n to be half, and then your x to be 2 over 3x. Then you finish up by expanding up to x to the power 3. And then it's only valid when 2 over 3x is less than 1. And then the absolute value of x is less than 3 over 2. And then you finish it up like that. So this one here is not very much different from the one that we did on question 3. Let me just go back. Yeah, they are not very much different with this. But either way, yeah, they are not very much different with this. The only difference is that this is a root here. The denominator is the root, meaning the other way I can write this is 5 over, then the root there, instead of writing the root, I'll write it as 5 plus x, and then everything to the power half. And then this can also be written as 5 open brackets 5 plus x to the power negative half. So this, when you want to express it now in the form 1 plus a to the power n, you can do it the same way we've been doing these other ones, where you say the 5 is there, you open these types of brackets, and then you write your 5 there. You factor out the 5, you're going to have 1 plus x over 5. So we're going to have 1 plus x over 5, like that. And then you raise everything to the power negative half, like that. Then you say equals, so you distribute the power there. You're going to have 5, then open brackets. This is going to be 5 to the power negative half. And then open brackets, 1 plus x over 5. 1 plus x over 5 to the power negative half. So this is just the same as 5 over the root of 5. When you simplify it, then open brackets, 1 plus x over 5, then everything raised to power negative half. Then from here now you can expand it. It's straightforward. You can use the extension to expand. So you expand everything there, taking into consideration that your n is negative half. So your n is negative half. And then your a there is x over 5. So your n is negative half and your a there is x over 5. And then you expand it using the extension. So when you expand it using the extension, you come and multiply everything by 5 over the root of 5. Right, to proceed. So this is what I was saying. And then it only occurs when this part here, it only occurs when x over 5, the absolute of this is less than 1. So meaning the absolute of x is less than 5, which implies that negative 5 is less than x, which is less than 5. And then in other ways, you can write it as negative 5, comma 5. In set notation, of course, don't forget to put x this side. So we proceed. So this one again, this one is straightforward. So for this one, I'll show you how to simplify it. And then expanding it is not that difficult. So this one can also be written as the square root of 1 minus x, then everything over the square root of 1 plus x. Then we can also write this as open brackets 1 minus x to the power half. And then everything over 1 plus x to the power half. So this can also be written again as you take this denominator up there, you take the denominator up, so it's going to be 1 minus x. Yeah, the time is started counting down now. So this is 1 minus x to the power half, and then you multiply it with 1 plus x to the power negative half. So you remember the example that we did when we were just starting, when you're multiplying two expansions, given the term on which you are supposed to end. So in our case here, they've given us that we have to end on the term x to the power 3. So meaning you expand this up to x to the power 3 and expand this up to x to the power 3 and then multiply the two and only get terms that are having the degrees either equal to 3 or less than 3. So you expand this one alone. Time is limiting us. Okay, you expand this one alone, where you say 1 over half x, and then plus 1 over 2, and then you subtract there, you get negative 1 over 2. Sorry for that. And then this is 2 factorial. Then plus, you keep on going like that. You expand up to the term where, this side is supposed to be x squared. You expand up to the term that is going to give you x to the power 3. And then you also expand this one up to the term which is going to give you x to the power 3. This is going to be negative half there. Oh no, sorry, not negative half. It's going to be positive. It's going to be something like this. So you expand even this side up to x to the power, up to x to the power 3. So you expand like that up to x to the power 3. And the way you multiply this, you don't start multiplying them one by one. You just check this one. When you multiply it to x to the power 3, you are going to get something that is going to give you x to the power 3. And then when you multiply this half with 1, you get half x. So you can write half x. You can expand. You expand it. I don't know, but you expand it with wisdom. If you just use the, I would call the cumbersome way of expanding, you would take long. Okay. So this is one of your exercises. I just want to know whether you've understood or not. You're going to submit in due time. So that is how you do it. This is how you do it here. So I also handed here, but you can expand further than this. So this is also in one of your questions that I've given as your exercise. So once you finish doing your exercise, please make sure that you submit before our next lesson, so that I see whether you've understood or not. And then where you have made a mistake, I'll correct you just right there. And then when you submit, you just take pictures and forward them on my WhatsApp line. Yeah, so this is the exercise I'm talking about. So the first one is saying, determine the value of each of the following, correct to 5 significant figures using the binomial theorem. We did this yesterday, so I'm pretty sure most of us can solve this. You just have to expand them up to x to the power 3 or x to the power 2. Yeah. So same applies to the second part here, saying expand in ascending powers of x as far as the term in x to the power 3 using the binomial theorem. State in each case the limits of x for which the expansion is valid. In short, we have done most of these questions here as examples, but the funny part is that I wasn't finishing them up. For you in this exercise, I want you to finish them up to the last solution. Yeah, up to the last point. So once you finish them up, you submit, and then I'm going to check whether you are correct or wrong. Where you are wrong, I'll correct you. All right. So this is the end of our lecture or our lesson today. This is the end. We're going to meet on Monday. And then if I see that you've understood trigonometry, you have no questions on any of the questions probably in your tutorial sheet or any questions that you find when you are studying mathematics. If you have no questions, meaning we're going to start trigonometry on Monday. So be there on Monday. We start together and finish together so that you don't miss out anything. So see you next time. If you have any questions, please, you can ask. Any contributions, any questions, you can ask. You can raise your hand there. There's an option of raising a hand. Then I'll be able to hear your concern. If you can't raise your hand, you can just send a text. I'll be able to see it from here. So I'm waiting for questions. Questions, please. If you have questions. So do you have questions? Questions. Do you have questions, please? Melvin, do you have a question?
No, sir.
All right. Gonza, do you have a question? All right. I think we can end the lesson. I don't think it seems like people do not have questions, which shows that I'm sure maybe you've understood. And so we're going to meet on Monday. We're going to start trigonometry, but make sure that you submit your work before Monday, together with the work that I gave you in that first lecture that we had. I need to see whether you're understanding or not. I've only received so far one person who submitted, and it shows that she understood, because she got everything correct in the first time. All right. See you next week, Monday.